Right, not to confuse you, I know the screen says section 1.4. We are chapter 1, part 3. We're a number behind. Talking about the atmosphere. And so another aspect of the atmosphere is pollution. Now, what is pollution? Harmful concentrations of gases or aerosols. So carbon dioxide, carbon, is in the atmosphere, right? Carbon by itself does not hurt you. If you get carbon blown on you, you're not going to melt. It's not poisonous. But if there's enough of it, it can cause a problem. Ozone is in the atmosphere. Sometimes it exists on the ground as ground level ozone. In very small amounts, it doesn't bother you. But if there's enough of it, it can irritate the linings of your nose and lungs and cause tissue damage. So pollution is only pollution if it's harmful. And that means basically that it has to be enough of it. Okay. Now, pollution isn't just man-made anthropogenic sources. There are natural sources of pollution. Volcanoes give off sulfur dioxide. When animals die and their bodies rot, they give off methane. And that's a natural source, as well as cars, exhaust, burning coal for electricity. So wildfires, a forest fire starts, burns all this wood, releases lots of carbon monoxide. Volcanoes put off tons and tons of carbon and sulfur. Most of the man-made pollution that comes into the world is from burning fossil fuels. So that's coal, oil, natural gas. That is the vast majority of pollution caused by man. We can break pollution into two categories, primary and secondary. So a primary means the pollution enters the air directly from its source. We burn coal in a factory and that smoke has sulfur dioxide. That's a primary pollutant. You turn on your car, the car burns gasoline or diesel fuel and it puts out exhaust gas. That's a primary pollutant. A secondary pollutant, sometimes these primary pollutants, when they enter the air, they interact with other chemicals or sunlight and change. So to use that first example, if you burn coal, the burning of the coal releases sulfur dioxide into the atmosphere. That's a primary pollutant. Sulfur dioxide in the atmosphere can bond with water in clouds and create acid rain. So acid rain would be a secondary pollutant. Sorry. So, for example, carbon monoxide, which is CO2, right? Natural sources are fires, basically a lot of things that burn, but natural emissions far exceed what we give off. People give off CO2 when they burn forests or burn things, but the difference is that natural sources of carbon monoxide are dispersed throughout the atmosphere of the Earth, whereas human sources are concentrated. So here's a good example. This map shows you CO2 levels. The darker the red, the more there are. And you can see that over the course of the year it changes, and there's a hot spot right here in Africa in winter. And that is actually due to the burning of forests to clear land for crops. Right here in China, there is a consistent high level. High levels here in North America due to industrial actions. I briefly touched about this. Sulfur dioxide, or SO2, is another primary pollutant. Volcanoes give off a lot of it, but so does fossil fuels, mainly burning coal for electricity. That's the main chunk of it. Acid rain is a secondary pollutant that is caused when sulfur dioxide, as I mentioned, it basically bonds with the water in the cloud to create sulfuric acid. Now, sulfuric acid can harm you. It's the same thing we use to clean pools. One drop of rain, 2 drops of rain, being caught out in a rainstorm is not going to hurt you. But what happens is, over time, it will build up. And so what happens is, areas that are in the path of acid rain, maybe you have a factory and it's putting off sulfur dioxide every day, year after year. And as the wind blows, it blows it to the south, to the north. So areas far away from the factory often are the victim of acid rain. And it can actually melt rock over time. It can change the soil. Here's an example. If you've ever seen these old statues or old stone statues in cities, like in Chicago, you find many of these where they're kind of almost like they're melted. This is a very old statue, probably 200 years old. Over 200 years of being in the rain, it eventually just melts It actually eats away at the outer surface. Whenever you're downtown, usually when we're teaching in class, at this point I look to one of the windows. We see one of the buildings next to the school, and you can see all these kind of like streaks going down the side of the building. It looks like, almost like the building's dirty. That's actually just the effects of acid rain over years. Here in North Carolina, this forest has been the victim of acid rain. In Chicago, for years, we had huge factories which blew their acid rain this way to the Smoky Mountains. And over time, it changes the soil chemistry, and trees begin to die. By the way, uh, things are acidic on a scale of 0 to 14. So if something that has no acidity whatsoever is even as neutral, that's water. So acid rain is just a little bit more acidic than coffee and a lot less than, say, lemon juice. So that's to give you an idea. Another major pollutant is nitrous or nitrogen dioxide, and this mainly comes from cars. In fact, it's one of the main components that cars put off, and a lot of the new technology with cars concerns how to get rid of this or how to, I guess, take this pollutant out of the air. Um, this is the thing that whenever you're by a highway or in a parking lot with a lot of cars, you kind of feel it in the back of your throat, that kind of taste. That's actually nitrous dioxide, and it's causing, with chronic exposure, can lead to huge problems. It's also why people who live next to highways, people who live next to very busy roads, we tend to find in those neighborhoods higher levels of childhood asthma, of lung disease, of bronchitis, um, and it also comes from burning coal. Another one is VOCs. These are basically organic compounds of hydrogen and carbon, like methane or butane. Uh, Sometimes you'll notice these in paint. Paint used to have that smell. They actually make paint now that has less of these. They call them low VOC paint. Okay, but if you've ever been to a gas station, right, and you pump that gas and there's that kind of metallic smell, that is a VOC. And that metallic smell is actually irritation, and in larger amounts can cause very severe damage. So an anthropogenic source would be automobiles, airplanes, but there is some natural actions as well. What are some secondary pollutants? Well, we talked about acid rain, but another one is photochemical smog. The nitrous oxide that cars put off, when the cars let it out of their tailpipe, if it's a bright sunny day, the sunlight can actually change that and turn it into ozone, which is a form of oxygen. Now it's interesting, I just mentioned it before, that ozone in the upper atmosphere is very good for us. It keeps us safe from the ultraviolet radiation. But when it's at the ground level, it is very, very harmful. And another secondary pollutant, this is kind of a catch-all, particulate matter. These are basically small things in the air, like dust or dirt or soot from smoke. When there's a forest fire and it's really hazy, that's particulate matter. It can be very, very small, fine things. All of these irritate the nose, the lungs. But ground level ozone, when it happens, when it forms, it can be very, very harmful to our lungs, to our breathing. It usually happens in the summer because that's when we have the most sunlight. So what happens is we see a lot of ground level ozone in cities in the summer because this combination. You have a city with lots of cars, so lots of engines putting off smoke, lots of lawnmowers, lots of small motors. And then if you have a day like that where there's a lot of hot sun, you can create much more ozone. And you can actually find this if you look at a weather report. A lot of the more detailed reports will actually tell you the air quality index. They're looking at things like ground level ozone, particulate matter, because if you have asthma or you have breathing difficulties, on a day like this, you need to be inside. Okay. By the way, particulate matters are aerosols. They could be liquid or solid. Okay. So it could be dust, it could be acid rain, smoke, it could be anthropogenic carbon soot, vegetation. It could even be small pieces of animal dung. Yes. In our country, it's mainly from coal. Now, if again, the big thing with all these pollutions, one of the biggest things is that it can make anything you have worse. So if you have bronchitis, if you have a lung disease, particulate matters can make it worse. It can aggravate things. It can also enter the atmosphere with dust storms. If something happens to the environment where the natural ground cover is gone, there's more open exposed dirt, wind blows through, whips it right up. What gets rid of particulate matter? Time. Eventually these things will settle out. So if you ever like throwing dust up in the air, if you let it sit, it eventually will settle out, right? Or rain. The rain will actually wash it out, or snow. Sometimes I've actually seen it. You might have seen this too. Sometimes the snow will actually look a little brown or a little dirty. A couple of years ago, there was a huge amount of forest fires up in Canada. So there was a lot of soot in the upper atmosphere, and it was early in the winter, and it started to snow, and the snow fell through that. It came down and was slightly brown. This next map just shows particulate matter on average over these 5 years. And you can see the most particulate matter actually tends to be right here. And I'm going to say, think about why this would be. Does anyone know what this area of the Earth is? For those of you who answered or didn't answer, this is the Sahara Desert, one of the largest deserts, a lot of sand. And then look over here, China, a lot of particulate matter. They have a high level of industry, a lot of pollution. You can see the United States and Mexico right here. Wherever there's more people, you see more particulate matter. All right, we're going to pause right here, and we'll come back with our next video in just a little bit.